Electron configurations build on the topics of electrons. There's an earlier video that looks at electrons and some information that you'll want to know, as well as orbital diagrams. Specifically that orbital diagram video. If you haven't watched that yet, make sure you stop here and take care of that first. So when talking about electron configurations, it's really handy to have a periodic table present and easily accessible. So if you don't have one right now, go ahead and grab one so you have it to look at as I'm walking you through the examples we're going to do here. And what we want to remember about the periodic table is the significance of the rows and then the different chunks of the periodic table and how they relate to, whoops, not helium, get rid of that, how they relate to electron shells, subshells, and orbitals. So remember that your first row of the periodic table, that the row equals the shell number, except in the case of the D subshell. And for the D subshell, we find that the shell number equals the row number minus 1. So if I was looking for the 2s subshell, that 2s, this 2 tells me the shell number, and it also tells me the row number on the periodic table. So the 2 s's would be in the second row somewhere. The columns of the periodic table, and this one is really handy because it has color-coded them. These purple columns we know are the S subshell. These pink columns are the D subshell. The blue ones here at the end are the P subshell. And these yellow ones here at the bottom are the F subshell. So if we were looking for the 2s, we would go to the second row, to the S block, and we would see that these guys were in the 2s. So hopefully that's a quick information about where things are in the periodic table. So if we want to do an electron configuration, there's some guidelines that help us know how to do it. And let's consider the electron configuration. And notice I say complete electron configuration here. That's versus something called the noble gas shortcut, which we'll talk about here before the end of the video. So the fact that we're asking for complete means we're not asking for this. So this shows me 1s2, 2s2, and supposedly that's the electron configuration for helium. What you want to notice here are the shell numbers are written first. So these numbers right here tell me the shell number. That's followed then by the type of subshell. So this collection here tells me I have the 1s subshell. And then finally, there's a superscripted number for the amount of electrons present in the subshell. So by saying 1s2, we're saying that in the 1s subshell, there are 2 electrons. That's what that tells us. So then for helium, we have 1s2, 2s2. It tells me that I have 2 electrons in the 1s and 2 electrons in the 2s. Notice there's no commas, no periods, or other punctuations present in the electron configuration. Notice also that those, the way that this was written, the 1s2, that the 2 was superscripted. So it's up here, not down around, looking something like this. Don't do that. I think I just wrote on something I'm going to be doing, so we'll erase that. So no punctuation in your electron configurations. Also, all of the electrons present in the atom are listed in the electron configuration. So helium, if we look at the periodic table, we can see has 4 electrons. So in its electron configuration, 1s2, 2s2, we should find those 4 electrons. And indeed we do. There's 2 here, and there's 2 here, for a grand total of 4 electrons. The electron configuration tells us that 2 of those electrons are in the 1s subshell, and 2 of those electrons are in the 2s subshell. Okay, let's actually do one of these together. And again, as I do this, I'm going to reference a periodic table. And I may flip back and forth between these here to illustrate what I'm doing. But you'll want to have yours out so you can follow as I go along. So let's start with cobalt. If I want to do the complete electron configuration for cobalt, that means I need to figure out where all of the electrons in cobalt are located. So I'm going to go back to, whoops, not that way. I'm going to go to my periodic table here and find cobalt. And here is cobalt right here. And I notice that cobalt is present in the D subshell. I also notice that cobalt has 27 electrons. How do I know that? Well, it's not an ion, so it's a neutral atom, so it has the same number of protons as it does electrons. So we're looking at cobalt, which has 27 electrons, and we need to figure out where all 27 of those go. When I look at the periodic table, it helps me, because essentially I can start here with hydrogen, and I can say, okay, this box represents 1 electron. So there are 2 boxes in the first row here, and we know from our just discussion that this is the 1s. Because there are 2 boxes, there are 2 electrons, so we say 1s2. At that point, I've covered those 2 boxes, and I'm going to go down here and look at these 2 boxes. Notice I'm grouping them according to color because I'm grouping them according to subshell. I'm in the second row now, so I'm going to say 2, and I'm still in the S block, so 2s, 2 boxes, so I have a 2 superscripted. Next, notice I'm moving in order. So this was element number 4, so now I go over here to find element number 5, and there are 6 boxes, all of the same type. We're in the second row in the P block, so that is 2p6. Okay, all done with those. Go down. Now I'm in 3s2 because I'm in the third row. Took care of those guys. Come over here. And still in the third row, now I'm in the P's, and there are 6 boxes, so 3p6. That's all good. Haven't made it to cobalt yet, so I have to keep going. I'm going to come around to the next chunk. See that that is the 4th row, the S block, and there are 2 electrons, so 4s2. And now I'm going to count over to cobalt, because I have 1, 2, 3, 4, 5, 6, 7 electrons in this subshell, which we know is a D subshell. This is in the 4th row, but we know that for Ds, the shell number is going to be row number -1. So this is the 3 Ds, and I have 7 electrons, so it is 3d7. Okay, now that I've totally mucked that one up, let's go ahead and do bromine. How about you take a moment and try bromine on your own, and then we'll come back and do it together. Okay, so for bromine, we're still starting in the same place. We still start with hydrogen and helium, so we still start with 1s2. Then we go down 1 level, and it's 2s2, and then across to the P's, and it's 2p6. Down to the next row, which would be the 3rd row in the S block, 2 boxes, so 3s2. 3p6 comes next, 4s2, then I'm in the D's, row number -1, got to remember, so 3d, there are 4 boxes, so, 10 boxes, so 10 electrons, so 3d10, and then I need to go over to bromine, which is 5 boxes in to the 4p subshell, so it's 4p5, and there is my complete electron configuration for bromine. Okay. I mentioned that we might not always have to do the complete electron configuration. There is something called the noble gas shortcut, and we're going to consider arsenic and technetium here. Arsenic, if we were to do the complete electron configuration for arsenic, it's just like bromine, except it has 2 less electrons in the last subshell. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then 4p5. So that would be the complete electron configuration for arsenic. The noble gas shortcut is I need to go to the last noble gas that I went to on the periodic table. And if you look back 1 row, from arsenic, you'll see that the last noble gas was argon. And argon's electron configuration looks exactly like this. And so the noble gas shortcut is we take all of those electrons up to my last noble gas, and we represent them as the element symbol of the noble gas written in brackets. And then we simply finish off the rest of the electron configuration. So this would be the noble gas shortcut electron configuration for arsenic. For technetium, Tc, I have to find Tc on the periodic table. Oh, I'm totally missing it. Let me go back here. Let's find Tc. Oh, here's Tc, right in the middle. So element 43. You'll notice here, let me erase all this other stuff so you can have a clear understanding of what I'm talking about. Okay, here's Tc. The last noble gas that I went through is behind it, and it's krypton. So it's one row above. So the noble gases, remember, are our last column. So to do the electron configuration for technetium using the noble gas shortcut, I start with krypton in brackets, and then I just finish off what's left. So there's 2 electrons. We're in the 5th row, so that's 5s2. And then D's are going to be row number -1, so 4D, and it's 1, 2, 3, 4, 5. So 4D5 would be my noble gas shortcut electron configuration for technetium.